Hi everyone, welcome back to our channel. I hope you and your family members are doing good because that is the most important thing, and for rest we are here to talk. So we were following our pattern wise DSA sheet. In this we were doing linked list topic and the pattern was merge and sort pattern. Today we will see the last question from this pattern, which is merge case sorted lists. So the prerequisite for this problem is merge two sorted lists. So if you have understood this question where we are merging the two sorted linked list, in the last question you have to merge sorted linked list, but instead of two there will be k different linked list. So let's read the problem statement. So as you can see, the list of linked list will be given, and if you see the constraint k is nothing but lists of length, means how many linked lists are there, that represents k, okay, and the linked list length, which is list of I of length, means in a single linked list the number of nodes can be 0 also, means we have to write the base case, and it can go till 500. So if you are thinking the number of nodes are very small, for one linked list the size is 500 and the number of linked lists are 10 power 4. So in total, can I say the total length of linked list will become 10 power 4 into 500, which is altogether 5 into 10 power 6, correct? Although it will not give TLE. Why? Because we know that beyond 10 power 8 our code is not safe, and for sure at 10 power 9, 10 power 10 it will give us TLE. So at 10 power 6 our code will be slower, but it won't give TLE. How? Because we have learnt about time and space complexity in our full video. I'll attach the link somewhere here. Okay, so what we have to do is, all the linked lists are already sorted. Now our task is to merge everything and make a single linked list. So guys, remember, in this question we will see 4 different approaches to solve the same problem, and the very first approach will be the brute force approach. Suppose you don't know how to merge two sorted linked lists, okay, which is a prerequisite of this video. So the very simple approach is ki, okay, let's iterate in this linked list one by one. Okay, so let's run the for loop of type list node and let's see one by one all the head from the lists, correct? Now our head does not become null. Okay, so what is this? At first the head will be the head of the first linked list. Until this becomes null, we will keep iterating in this and read all the values to store in some another array. Okay, so let's say that another array is nums. So in our nums we will add what? Can I say head dot value? Yes, and we will move our head ahead. Head is equal to head dot next. Done. So can I say at first the head will become this, and one by one it will go read all the values, and in the nums array it will insert 1, 4, 5, correct? Now next time when while loop will get over, the for loop will take the new linked list and I start iterating from the head. So again it will say 1. So 1, 3, 4 will get added in the nums array. Can I say 1, 3, 4? Similarly, next time 2, 6. So this is the nums array we have, correct? Now our task is to sort it, correct? Yes, because after you inserted all the linked lists which were earlier sorted, but now after insertion in the nums array it's not sorted. So further it will take n log n time complexity to sort this array, can I say? So after this, after sorting, the linked list will look like 1, 2, 3, 4, 5, 6. Done. And now we can create a new linked list. Yes, one like with a dummy node. Always create the linked list with dummy node, and to its next connect 1, then 2, then 3, then 4, then 5, and then 6, correct? And at the end dummy dot next you can return. Very simple. So first, so what is the time complexity to iterate here? This for loop is going to iterate for k times, can I say? K times. And further this is going to iterate for n times. N is nothing but number of nodes which were max 500 and k was max 10 power 4. So can I say it's O of k into n, which is 5 into 10 power 6 in total, 10 power 4 here and 10 power 2 here, correct? Now space complexity. First space complexity here, because we have taken or created extra array list. Okay, and then further at the end we have created the new linked list. Although if we ignore this, because anyhow we have to return the new linked list, right? But what about this? This is extra, right? So this can be the brute force approach. This can get submitted because the constraints altogether k into n makes 10 power 6. So this will get submitted for sure. But what if k was also 10 power 6 and n was also 10 power 3? Means altogether it will become 10 power 9, and there when 10 power 9, you know, it will give us TLE, correct? So in that case, we cannot submit this brute force code. So this is how constraint decides ki whether our brute force code will work or not. So here it will work. So can we write the code? So here is the code we have discussed. Array first we'll create. Now we will iterate in the list one by one, and with the help of head pointer, we will iterate in the entire linked list for k times. Now once submitted or inserted in the nums, we have to sort it. Now we have to make a new alias current. Now one by one, pick up all the elements from the array after sorting, and in current.next just create a new node with that value and move your current pointer ahead. At the end, dummy node is 0, so obviously to its next will be my new head. So can we run the code for this? Yes. Now let's try to submit this. So the time complexity for this case is O of k into n. It will be slow, as you can see, but it gets submitted. Why? Because constraint was, all over constraint was 5 into 10 power 6. Okay. But now, don't you think, guys, ki because the question already mentioned ki these will be sorted in their own, then why we have inserted and applied sorting further? That extra n log n to we can reduce, na? Correct? So total time complexity for that case was, this to was taking O of kn. Correct? And this was taking further O of kn log kn. Now why? Because see, O of kn to insert all the values one by one here. Now to sort any array of length, let's say L, it takes L log L, remember? Now L is nothing but kn. So kn log kn, correct? So that's why the time complexity will be 10 power 6 log 10 power 6 base 2. Okay? Now, as it is already sorted, so what approach we should think for? You know that. Yes. And that's called merge algorithm. Yes. When two things are already sorted, let's merge them together. And the merge algorithm we have already discussed in our previous videos. I'll attach the link somewhere here. But in short, we are going to explain here. First 1, 4, 5 and let's say 1, 3, 4. Let's consider these two we have to merge. So we will start our L1 pointer, we will start our L2 pointer. Okay. And let's make a dummy node. Now to its next, whatever will be smaller, we will connect. Now we will compare L1 is smaller or L2. It's equal, so let's consider L1. So L1 we will connect. Now current here. So current will also move ahead. And as we have taken L1, so L1 will also move ahead. Now in the next time we will compare L1 is smaller or L2 is smaller. It will say L2 is smaller. So to its next, L2 will get connected, which is 1. Now L2 will move ahead. Now current will also move ahead. Again, L1, 4 is smaller or 3 is smaller? We will find 3 is smaller. So in current.next, L2 will get connected. Now current will also move ahead and L2 will also move ahead. Now further, L1 is smaller or L2 is smaller? Okay. So now in this case, you will connect L1, you will move current ahead, you will move L1 ahead. Now again L2, so 4 will get connected, we will move current ahead, we will move L2 ahead. Now L2 has become null, so we will stop. Now whatever is left over in L1, we don't know what if 5, 6, 7 and so on. Now why to iterate here? We know already it's already sorted. So why not to connect current.next with whatever L1 is? So L1 is 5. Now 5 is already having the address of 6. So 6 will also get connected. Now 6 is having the address of 7. So 7 will also get connected and we are done. So what is the time complexity here? O of m, like length of this plus length of this, that's it. So if there are, suppose the length of linked list will be n and the number of nodes were 2. So the total time complexity will be 2n, correct? But here it says k, number of linked lists are k and n. So can I say kn? So in the previous approach, it was kn log kn, and here it will be simply kn, which is far better approach. But although kn will also be 5 into 10 power 6. So this will also be slower, but we can do this. Now, why I said kn? See, First we will merge both of these, correct, and we will make one. Done. Now in the next call, we already know that these two are already merged. Now in the next call, answer of this, which will be 1, correct, we merged it, so the now new linked list is only 1. Now that one linked list should be merged with this, so all together this. So what I am saying, let's say we have 1 linked list, we have 2 linked list, we have 3 linked list, we have 4 linked list. Okay, I am saying merge both of these, so answer will become new 1. Now merge 3 with this, so new answer will become this. Now merge 4 also with this, so the new answer will become, can I say this? Yes. So that is our task, is merge 2, answer become 1, like 1 linked list I am saying. Okay, now the new 1 linked list needs to be merged with the next one. Now again the new resultant linked list needs to be merged with the next one, correct. So don't you think we are taking one by one every nodes? So that's why it is k into n. Okay, now we have already discussed about how to merge 2 sorted linked lists. So if you know that, you just need to call one by one by sending this linked list and this linked list in the function, and you have to write the same function which we have discussed. So I am assuming you all know that approach, so we are directly going to write the code. So this is the approach which we discussed. First, the base case, because the question saying the constraint, the number of nodes can be 0 also, correct. So what if my list is null, or the length of list is 0, then we can say we don't have any linked list to return null, or else let's create a new linked list result will be nothing but 0. Why I am saying this? See, let's start iterating from here. Okay, this, and in the resultant, let's say answer, we will start with this, because we have already checked our base case ki there should be at least 1 linked list. Yes, it is there, so that will be our answer. Start iterating from here. So in the function, just send answer and list of I. Now whatever this function will return, save in new answer. Now again next time function, so answer, the new answer will be the merge of these two. Can I say that? And then again list of I. So next time list of I will be this. So that's why. So let's initialize result with list of 0 and start iterating for loop from 1 till last. In the function which is merge, we will send result and list of I. Now after merging, whatever the new linked list will be, that we will save in the result, so that next time this result needs to be added with the list of I, and at the end we will return the result. Now let's see in the merge what we are doing. This merge code we have already discussed in our merge to sorted list code. So I am not going to explain the code again, because we just have discussed in our pseudo code. So here is the code for merge to linked list. So one by one we will merge it. So that is why the time complexity to merge any 2 linked list is 2n. Can I say that? But we are merging k different linked lists, so that's why it is kn. Okay, so now let's submit the code. For this, the exact time complexity will be 5 into 10 power 6. But if you're talking about space, we are taking extra space complexity because of creating these linked lists again and again, correct? So that's why this is also not the optimized code, because the constraint is acceptable. It's not so large that the kn is going out of index, so we can still submit this. Okay, but for the interview, what's the most optimized code, that we will discuss. So let's see the third approach, which is using the priority queue. But why to use priority queue? See, the idea is very simple. We need to make the linked list and the first node need to be very small. Then instead of comparing and finding the smallest element in all, why don't we do one thing? We know that all are already sorted. So just start picking the first elements and then find the smallest in that. Now instead of taking n into k time complexity, we have to find the smallest element in just k. Why? Because k is a number of list, and out of all k list we are just taking one element. So that's why instead of taking n into k time complexity, n to we cannot reduce because we have to make the nodes, correct? But the k we can start playing with. Okay, so the idea says कि let's make a priority queue, and in this just pick all the top elements, which is 1, 1, 2 and 2. Okay, now instead of saving it as number, let's save in the form of nodes. Okay, now as we have to make the nodes, so let's make a dummy node, and in this let's start iterating with the current pointer, and to its next we have to pop the smallest element and we have to put it. Now as we are popping it, So it's very important to pick, like to keep the next node. Why? Because if you remember, in the merge to sorted list, when we started with our L1 and L2 pointer, when we decided to choose L1, then we moved our L1 also ahead now. So as we have popped our node, so it's very important to check first if our node dot next node is not null. Okay, then in the priority queue, please offer node dot next. Okay, so now 4 will get inserted, correct? Now after this, current will also move ahead. Now next time, next node will get popped, which is 1, and for this one, 3 will get inserted. Now this 1 will get connected and current will move ahead. Now next time, the next smaller element, which is 2, will get popped, and for 2, 6 will get added. Now 2 will get inserted here as node and current will also move ahead. Now next time, this 2, for this 2, 5 will get inserted, 2 will get connected and current will move ahead. So don't you think we are picking the smallest element, but priority queue will take just logarithmic of k time complexity to choose which is the smallest element here, correct? So now again for the next smallest element, which is 3. Now for 3, next element is 4, so 4 will get inserted here and current also will move ahead. Next time 4 will get inserted. For 4, what is the next element? 5. Again next time current will move ahead. This 4 will get popped, and for this 4 we have nothing in the next, so we won't put anything. Okay, now next time 5 will get popped and connected here. Okay, now for this 5 we have nothing, so nothing will get inserted. Now again current will move ahead at 5, and as next time 5 will get popped, 5 will get connected, but for this 5 we have 7, so 7 will get inserted. Next time 6, next time 7. So basically O of n times we are taking to fill this linked list, but instead of n into k, for every element it is taking just logarithm of k to find the smallest element. So that is the reason the time complexity has been reduced. Okay, so I hope you know how the priority queue works. Basically it maintains a minimum number or maximum number, and it looks like tree data structure. So let's write the code for this. So here is the code. First we will make a priority queue and we will do a value minus b value. Why? Because it will maintain the minimum heap. And by the way, in Python it is very easy. In Python you just have to write minus of any number to become the min heap, to act like min heap, and plus it will act like max heap. Now we have to iterate in the entire list. One by one we have to read the head node of every linked list and just store that first node in the priority queue. Now we have to make a dummy node and start our current alias. Now until the priority queue becomes empty, we have to pop every node, like single node from the priority queue. So can I say at first our priority queue will look like 1, 1, 2, considering the example number 1. Now in current.next, as it started from 0, so can I say in current.next 1 will get added? Yes. Now in the priority queue, as 1 has been popped, so its next node, which is 4, will get added, correct? So from here 1 will get popped and 4 will get added, but as it is the minimum heap, so it will rearrange itself 1, 2, 4. Done. Now next time 1 will get popped again, and for it 1.next, which is 3, will get added. So from here 1 will get popped and 3 will get added, but as it is min heap, so 2 and 3 will rearrange itself. Next time 2 will get popped, 2 will get added also, but for 2 next we have 6, so 6 will get added. So from here 2 will get popped and 6 will get added. As this is a min heap, so 3, 4, 6, it will rearrange. Next time 3 will get popped out. 3.next we have 4, so 4 will get inserted. So 3 will popped, 4 inserted. Next time 4 will get popped out, connected. Now for 4.next we have 5. So for 4 will get popped, 5. Now it will rearrange itself in 4 and 5. Next time again further 4 will get popped out. For the next 4 we have nothing in the next. So we will not insert anything in the priority queue. So 4 will get popped out. Next time 5 will get popped out. For 5 again we have nothing in the priority queue, so we will not put anything. Like for 5 to its next we have nothing, so in the priority queue we will not put anything. So 5 will also get popped. Now next time 6 will get popped. For 6 next we have nothing, correct? Yes, so again in the priority queue nothing will get inserted, and now we can say our priority queue is empty. So this is the node we have, linked list we have, but do we need to send from 0 because 0 is held by its dummy? No. So we have to send from here. So that's why we have to send return dummy.next. So this was your code. Let's run this and let's submit this. So So the time complexity for this code is n log k and space complexity is O of k. Why? Because that is taken by the priority queue. So this was your code in Java, here is your code in C++ and here is your code in Python. So I hope you understood. So if you understood the brute force approach, then merge all linked lists together, then the priority queue approach, and the last one, divide and conquer, and with the proper notes, then you are eligible to go in our sheet and mark the last question of this pattern as done. So I hope you understood. If you have any doubt, do let me know in the comment section, and if you want the link of the sheet and want me to connect, then you can get the social media links also in the description. That's it for this video. Let's meet in another video with some more interesting questions, topics and patterns. So then keep learning, take care of yourself and your family too.